today's chemistry class, we are going to be discussing on oxidation number. What is oxidation number all about? We are talking about the valency, the combining power. Just remember when we did something about electronic configuration, we talked about the valency. Now, the oxidation number is a charge on that valency. Remember, I said something that, like sodium, for example, atomic number of sodium is 11. Electronic configuration is 2, 8, and 1. This 1, which is the number of electrons on the outermost shell, that one is the valency of sodium. Magnesium with 12 will be 2, 8, and 2. Aluminium with 13 will be 2, 8, and 3. So these are the valency of these three elements. When you have 1 on the outer shell, like in this case, 2 on the outer shell, like in this case, 3 on the outer shell, like in this case, those elements are metals, and their number of electrons on the outer shell are their valency. They can give out easily. But when you have more than 4 and above in the outer shell, now you are now going to consider the number of electrons that will come in to be their valency. For example, if we say nitrogen atomic number is 7, and you have 2 and 5. 5 is more than 3. Remember this 1, 2, and 3, it stops there. They are very few as to compare with 8 on that shell. That shell is supposed to carry maximum of 8. But since it is 1, 2, or 3, it's not even up to half. Half is 4. So it can easily give out. And those ones that have those number, they are metals. They can easily give out. But those ones that have like 5, 4, 5, 6, 7, they are non-metals. They will not give out because they have reached half of 8 that shell can carry maximum. So instead, it will borrow in the remaining number to make it 8. This man has 5, so it can borrow what? 3 to make it 8. And that 3 is its own oxidation state or valency, if I may put it that way. The one that has O, like O, which is 8. You have 2 here, 6 left. It will borrow 2. So this one will need 3. This one will need 2. Like fluorine. Fluorine is 9, and it will be 2 and 7. So this one will need 1. The few number of electrons that are coming in, those ones are non-metals. You not say that 5 is the valency, 7, 6. Instead, the number that will come in will now be the valency. Okay, I hope you understand that. Now let's move forward to what I want to teach. I said oxidation number is the charge on the valency of an element. You have now reminded yourself about the valency when we say valency. Now note 1, the total number of oxidation states of any compound is 0. So if I write like any of this compound, the total, apart from this, the total number of this, because this one has a charge, there's minus it. This one has no charge, This one has no charge, this one has no charge, no charge, no charge. So the total number of all the valency, that of nitrogen and oxygen, that of nitrogen and oxygen, nitrogen and hydrogen, nitrogen and oxygen, nitrogen and oxygen, their total valency is equal to 0. Note, very important. Now number 2 thing that you need to note also, some elements have fixed oxidation state while some have variable oxidation state. When I say that some elements have fixed oxidation state and while some have variable oxidation state, I mean that like those elements that I wrote here, those among the first 20 elements, there are some elements that their oxidation state is always the same. Anywhere you see it is always the same. Like oxygen. When you see oxygen, you remember that oxygen will borrow 2 electrons to make the outermost shell to be 8. Now, the minus 2 that comes in, remember when you borrow in, you carry minus. When you give out, you carry plus. So the minus 2 that are coming in is the oxidation state of oxygen at all time. That one is fixed. But when you say nitrogen, for example, nitrogen has more than one oxidation state. By the time we will be calculating this, you will see that the oxidation state of nitrogen here will not be here the same with that of this. That of this might not be the same with that of this. That of this might not be the same with that of this. So it keeps changing. That's variable oxidation state that we are talking about. Okay, so note that some have fixed, some have variable oxidation state. Now let's do the calculation of oxidation number. Example, calculate the oxidation state of nitrogen in the following compounds. 1. N2O. 2. NO. 3. NH3. 4. NO2. 5. NO3 minus 6 HNO3. Now let's see. Solution. The first one, it said we should calculate the oxidation state of nitrogen in this compound, N2O. So I said the oxidation state of nitrogen in N2O is what we are going to calculate now. I don't know because I told you earlier that nitrogen has variable oxidation state. It's not at all time the same. So it has different oxidation state. So we want to know which of the oxidation state that nitrogen is using in this compound. I don't know nitrogen, so I will say how many atoms of nitrogen that are here? 2. Now add that to the oxidation state of oxygen. I told you earlier that oxidation state of oxygen is what? Is minus 2 because it borrows 2 electrons into the outermost shell to make it 8. So that's the equate it. Remember I said that the total of all the oxidation states of any compound is what? Equal to 0. Equate it to 0. Once you are able to generate this up to this point, use your mathematical method to do the calculation. So now my 2n plus times minus gives me minus 2 equal to 0. Take this to this other side. You have 2n equal to, when minus crosses the sign of equality, it becomes what? Plus. That gives me plus 2. I am looking for n, not 2n. So divide both sides by 2. So I will now have 2n all over 2 equal to plus 2. 2 all over 2. So this will cancel out this, and this will cancel out this. You are now getting N equal to plus 1. This is the oxidation number of nitrogen in N2O. Now let's go to the second one, NO. Number 2, NO. We are still calculating the oxidation number of nitrogen in NO. Looking at that, N, I don't know the oxidation number of nitrogen in this compound. So I will now say N plus oxidation state of oxygen in this compound. Remember, I told you, I believe you can still remember, it's always what? Minus 2. Equate it to 0 because it has no charge. No plus, no minus attached to this compound. Like this one. This one has a charge. So we will not equate this to 0, but this one we will equate it to 0. Now use mathematics and solve the problem. So you now have N plus times minus 2 equal to 0. Take this to this side, you now have N equal to plus, it turns plus when it crosses the sign of equality, plus 2. So this is the oxidation number of nitrogen in this compound. You can see the first one was 1, now we are getting 2. Now let's go to number 3. Number 3 says NH3, oxidation number of N in NH3. So now I don't know N plus oxidation number of hydrogen here is 1 plus 1. How many of hydrogen are there? 3. So multiply by 3. Equate it to 0 since there is no plus, no minus. 0. Now multiply this place and you have N plus 3 equal to 0. Take this to this side, you now have your N to be minus 3. So your N in this compound, the oxidation number is minus 3. Okay?